Okay, so let's just quickly devise this one question. So this is physics and it's under electricity. Okay, so this is our circuit. We have the ammeter here, and here we have 6 volts. That's the battery. So this circuit is connected to a 6 volt battery. So 6 volt, which is here. So the battery there is 6 volt. We have 6 ohms here. So take note of this. So we have a 6 ohms, 4 ohms, which is this one. So if you see these two resistors are connected in parallel, so these are in parallel. So you should take note of these two are in parallel, and then this 0.6 ohms is in series. Okay, is in series. So if you see these 2 volts which are in parallel, you know how to find the total resistance when volts are connected, or when resistors are connected in parallel. So we use this formula to find the total resistor when resistors are connected in parallel. RT is equals to R1 multiplied by R2 over R1 plus R2, where RT is the total resistor and R1 is the first resistor which are in parallel. So here our R1 is 6 and our R2 it's this one. It's this one. So this is the formula we use when calculating the total resistors in parallel. So for the total resistors in series, we just add the series. So total resistor in series is equals to R1 plus R2, just the summation of the resistors when they are in series. So these are two important methods you need to master. So let's now look at the question. So this is the question. We have a closed circuit. As you can see, it's closed. We have ammeter here, an ammeter which is used to measure current. We have a 6 volt battery. We have 6 ohms, we have 4 ohms, and we have 0.6 ohms. So let's now begin our calculation. So on question 1, we have been asked to find the current across 0.6. So find the current across 0.6, which is this one. So how can we find the current which is passing through this resistor? So you know that when current comes from this side, it will pass. When current comes from this side, after reaching this point, some will go to this side and some will go to this side. After separating again here, the current will meet and pass through 0.6. So in short, they're asking us to find the total current that is in this circuit. So how can we do that? So the first thing that we need to do is find the total resistance. That's the reason I gave those methods, because we are required to find the total resistor. So let's find the total resistor. Okay, so we know that total resistance is equals to the summation of these resistors that are in parallel plus this. So let's first find the resistors, the total resistance in parallel. So we know that RT is equals to R1 multiplied by R2 divided by R1 plus R2. This is the formula. So RT is equals to R1 is 6 ohms. So here we're going to put 6. So we have 6 here plus R2, which is 4. Multiplied by, there is a multiplication here. So we have 6 multiplied by 4 over R1, which is 6, plus R2, which is 4. Here, when you multiply, we're going to so RT is equals to 6 multiplied by 4, it's 24. So 24 divided by 6 plus 4, which is 10. So RT in parallel is equals to 24 divided 10, which will give you 2.4 ohms. Remember, resistor is what's this? the SI unit for resistor is ohms, which is this one. Okay, so this is the total resistor in parallel. So here having found the total resistors which are connected in parallel, let's now find the total resistance in the circuit. So the total resistance can be found by adding this plus this plus this. So here we found the total resistance to be 2.4. So let's just do 2.4 plus 0.6. It will give us the total resistance in this circuit of ours. Okay, so 2.4, which is this one, the resistors, the total resistor in parallel, plus 6.02, it's going to give us 3 ohms. So total resistor is equals to 3 ohms. So this is the total resistor. And let's now find the current which is passing through this resistor, which is 0.6. So in short, they want the total current that is passing in this circuit, because we know that when current comes this side, here it will separate, again here it will meet, then pass through 0.6 ohms. So we have found the total resistance to be 3 ohms. So let's now find current. So let's find current. So we know that current is equals to voltage over resistance. So current is equals to voltage over resistance, and its SI unit is ampere. Okay. Yeah, so this is the formula used to calculate current. Okay, where V stands for voltage, R stands for resistance. So let's now find our current. So we have current is equals to voltage. We have found to be voltage has been given, and it's 6 volts, as you can see there. So where there is the V, we're going to put 6. So here we're going to have 6 over resistor. We found to be 3. That's the total resistor. We found 2.4 added to 0.6, which gave us 3 ohms. So here, when you divide 6, divide 3, it's going to give you current is equals to 2. Remember, in physics, the SI units are very important. So don't forget the SI units. So remember, we're finding current, and the SI unit for current, it's ampere, which is written like this. So this is the current passing through 0.6 ohms. Okay, so number 1 we have found, and our answer is 2 amps. So let's just write our answer here. So A is equals to 2 amps. Let's now go to B, which we don't know. Okay, so let's just create space. So on B, we have been asked to find the current across 4 ohms resistor. So let's find the current across 4 ohms resistor. And here, when resistors are in parallel, the voltage is the same, but current is different. Don't mix these things. When resistors are in parallel, the voltage is the same. So this and this are in parallel, so the voltage is the same. So same voltage here. But the current is different. Again, when resistors are connected in series, they share the same current, but voltage is different. That's how these things are. So let's now find the current across 4 ohms resistor. So how can we find the current across 4 ohms resistor? We know that these two share the same voltage. They have the same voltage. So let's just find the voltage which is passing through this resistor. Then we subtract from this to remain with the voltage that is in here, because these two, they have the same voltage. Okay, so let's find the voltage which is in this ohms, which is in series, which is 0.6. So we know that the voltage is equals to current times resistor. Okay, this according to Ohm's law. So this is Ohm's law, which states that voltage current is direct proportion to what's this? So voltage is direct proportion to current and resistance in a conductor. So this is the formula. So voltage is equals to resistance times current. So we know that current is 2 amps, which we found. So we're going to have 2 amps multiplied by a resistor, which is 0.6, because we're finding the resistance in this 0.6 ohms. So multiplied by 0.6. So V is equals to, so 2 multiplied by 0.6, it's 1.2. Remember, voltage is written in volts. This is the SI unit for voltage. So this is the voltage that is passing through this 0.6 ohms, and we know that the total voltage in this circuit is 6 volts. So let's now find the voltage that is in this 2 parallel resistor. So we're going to do this total voltage minus this voltage, which is near, will give us the voltage that will remain in this circuit. So we're going to have 6 minus 1.2, which will give us 4.8. So 4.8 volts. So 4.8 volts, which is here, 4.8 volts is the voltage that is passing through these 6 or these 2 resistors that are in parallel. And I've said that when resistors are connected in parallel, the voltage is the same. So in here we have 4.8, also here we have 4.8 volts. Okay, so let's now find the current. Having known the voltage, it's easy for us to find the current, because we know that current is equals to voltage over resistor. So current is equals to voltage over resistor. So current is equals to voltage we found to be 4.8. So 4.8 over resistor, which is 4, which is 4. Remember, we're finding the current in the 4 ohms resistor. So here we're going to have 4. So current will give us, so 4.8 divided 4, it will give us 1.2. So here we have 1.2 amps. So this is the current that is passing through this resistor. Okay, so through that resistor. Okay, so that's how you can find current across 4 ohms resistor. You find the voltage that is passing through this resistor, which is in series. Then you subtract from the voltage, the total voltage. Okay, then you remain with the voltage that is passing through here. Remember, these two share the same voltage, so it's easy for you to find now the current using one of the ohms needed. Okay, so let's now go to part C. Okay, let's just create space. Okay, so here B we found the voltage to be, or current to be 1.2. So here we have 1.2 amps. So let's now find C, which we don't know. So C says find voltage across 6 ohms resistor. So find voltage across 6 ohms resistor. So we have found voltage to be 4.8, because I said that these two share the same voltage. Okay, so here the main voltage was 4.8, so we have 4.8. So 4.8. So So 4.8 volts. So this is the voltage across 6 ohms. Let's now go to part D, which where we are required to find voltage across a 0.6. So here you can just do total voltage. So total voltage, which is 6 V, minus the voltage which is in these 2 ohms, which is 4.8 V. We're going to remain with 1.2 volts, if I'm not mistaken. Yeah, 1.2 volts. So 6 minus 4.8, it will give you 1.2 volts. So these are the answers. Okay, so this is how to tackle with this kind of question. So the key points here are resistors that are connected in parallel, they share the same voltage, and resistors in series, they share the same current but different voltage. Remember to subscribe and like the video.